Okay, so good evening. Do you have any questions from the previous class? Any questions? No? Okay, so let us start. So we'll be solving some of the problems based on the understandings whatever we have on equilibrium of forces in 3D, right? Right? Okay. So note down on problem. Equal forces act along the the coordinate axis and the straight line. And the straight line x minus alpha by L equal to y minus beta by M is equal to z minus gamma by N. Find the equations of the central axis of the system. Of the system, right? So this is the problem statement. Now let us see how we can solve this. Equal forces act along the coordinate axis and the straight line x minus alpha by L equal to y minus beta by M is equal to z minus gamma by N. Find the equations of the central axis of the system. Now actually, whenever we wanted to find out the equations of the central axis, so we have to be aware of two different aspects. One is the sum of all the resolved components of the forces along all the three coordinate axes. So this one important aspect, which is nothing but R, actually you have to be finding out as in the form of xi plus yj plus zk. And then you have to find out the resulting moment of all the forces together. So that is M, so G is equal to Li plus Mj plus Nk. So these are the two important things actually you have to be calculating for finding out the equations of the central axis. Now the equation of the central axis is nothing but, so L minus Yz minus plus Zy divided by x is equal to M minus Zx plus Xz divided by y is equal to N minus xy plus yx divided by z, right? So this is equal to Lx plus My plus Nz divided by x square plus y square plus z square. So this is these are the equations of the central axis. Now we have to be finding out these equations of the central axis with the information given. Now actually he is talking about total 4 different forces. 3 forces are along the coordinate axis, that is, so let us say this is the origin. Then actually from this point there are 3 different equal forces that are acting. So one along this axis of magnitude P, and another along this axis of magnitude P, and another at this axis of magnitude P. So that is equal forces act along the coordinate axis and the straight line. So three equal forces actually act along the straight lines now. And one more force, x minus alpha by L, y minus beta by M is equal to z minus gamma by M, where this is what actually will be giving the information, right? One is, so equal forces. So force magnitude is anyway independent. And then the location of the force or the point of application of the force. Can you tell me the point of application of the force? The fourth force. Can somebody give me an information about it? What is the location of point of application of the fourth force? Three forces actually are acting along the coordinate axis. There is one more force and he has given this information. Now here actually, exactly, right? Alpha, beta, gamma is the position. So that's why this is the equation of the straight line when it is passing through alpha, comma, beta, comma, gamma. Now alpha, beta, gamma is a point location where it is the point of application of the force. That means, let us say this point is alpha, comma, beta, comma, gamma. So this is the point of application of the force, and correspondingly in the denominator he has given LMN. Now actually we have to be aware of the direction of the force also, right? So one is the point of application of the force, from this you can get it, and one more information what you can get it from here it is, that is the line of action of the force. So the line of action of the force also you will be able to get the information from this equation. The line of action is nothing but the direction of the force. The direction of the force is always given by the directional cosines. The directional cosines are L, M and N. So these are the directional cosines. Now actually based on this L, M, N value, the direction of the force is going to be dependent on this. So this is L, M, N, which are the directional cosines. So these four forces are acting on a body. So maybe actually, so there might be one body like this on which these forces are acting like this. Now for this system of the force acting on this particular body, we have to be finding out the resulting, the axis equation, that is the central axis equation, which will give the direction of the equivalent force and the direction of the rotation also, which are very, very crucial, important informations for us, right? So that's what actually we have to be finding out, and the central axis equation is given by this one. Here if you notice L, M, N, which are nothing but, so the G parts, and then we have Z, Y and X. So X, Y, Z are part of R. Now these two, if you are able to find out for entire system of these four forces, then actually you will be able to arrive at this equation, because this small x, small y, small z are the variables anyway. You will keep it in the equation itself, right? So only information that you have to be aware of is one is G and there is R. So from this information we have to get the values of R and G. That is the first criteria. Once we got the values of R and G, you will be substituting in this equation to arrive at the central axis equation. And once you get the central axis equation, then actually you can use other relations like, so G is equal to PR. So this is another relation which you can make use. Anyway, you are aware of R and you are aware of G, wherein this P is the pitch of the wrench, as long as these two are the parallel vectors. Got it? So this is what are the relations what we can make use to find out the complete information about the system of forces in 3D. This is the only information what we are talking about in the entire topic. So whatever the fundamentals we have learned is to understand this equation and the implications of this equation. That's all. But those things whatever we learned is simply to support this. Got it? So if you are aware of this central axis equation and if you are able to find out, then actually for this particular topic you are done. Got it? Okay. So now actually we will be finding out this equivalent force, that is x comma y comma z values. Now from this equation, so we can find out the different components of the forces. Now actually we will be finding out this system of forces along x-axis, y-axis and z-axis components. So for force number 1, so let us say this is F1 and this is F2, this is y-axis, this is x-axis and this is z-axis. Let us say this is F3. Then, so for F1, we have actually 3 different components. One is x1, y1 and z1. Right? Or actually I will keep it here. Y1 and z1. Now similarly for x1, right? So what is the component along x-axis for F1? What is the component of the force along the x-axis? Tell me, what is the component of the force along the x-axis? All the force magnitudes are P, but the orientations are different and the point of application is different. Okay. So you are giving the complete information. So I am asking about if F1 is equal to x1 into I plus y1 into j plus z1 into k. And similarly, so F2 is equal to x2, y2, z2. Similarly, F3 is equal to x3, y3, z3 and F4 is equal to x4, y4, z4. Then actually I am asking only the component of the force for F1. So for F1 force, so we have got actually only Pi, nothing more than that. That means this x component is P and y component is 0 and z component is 0. Correct? Got it or not? This one. Right? Similarly, if you take F2, then actually we have got only 0 plus Pj plus 0. That means we have got only the y component and z component is 0. Similarly, for F3, if you calculate it, that is only z component is there. And then for this one, so this is crucial for us. Now what is the component along x-axis for this particular force of P, whose location of application is alpha comma beta comma gamma and the direction coefficients are L comma M comma N. So in such kind of scenario, what is the x component of the force? This is the only thing what you are learning now. So rest of the things are anyway known. What is the x component for this particular force? So that is FL. So we are calling this as P. So that is PL is the x component. And what is the y component of the force? Y component of the force. So that is PM and then Pn. So because the directional cosines are nothing but cos alpha, cos beta, cos gamma. So L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. So if this is the case, then P component projected on x-axis, which is making an angle of alpha, which is nothing but P cos alpha. Cos alpha value is anyway L. So P into L is nothing but the horizontal component or the x component. Similarly, PM and Pn are the y components and z components respectively. Now, so the sigma of all these things. So that means from the sum of all these things, you are going to get the horizontal components of the force. That means P plus PL, that is P into 1 plus L, is the component of all the forces together along x-axis. Similarly, for this one, P times of 1 plus M is the component of all the forces together along y-axis. And similarly, the last one is P times of 1 plus N, which is the component of the forces together along the z-axis. So this is capital X, this is capital Y, and this is capital Z. Got it? So we have got the R value. So R is nothing but, so this is Xi plus Yj plus Zk. And where this is X, this is Y, and this is Z. Got it? Any questions on this? Any questions? Okay, so you can note down this. Now actually, it is time to calculate the G value. So because we have already got the value of R. So R is equal to P into 1 plus L into I plus P into 1 plus M into J plus P into 1 plus N into K. So this is the R value. So G value to find out, so this is a little complicated equation. So for finding out the G value, so there is one methodology what we are going to adapt. So that methodology is, so in the first line, point of application of the force. In the second line, the component of the force. So these things actually we have to be writing for each force. Now if I take F1 and the point of application of the force is 0, 0, 0. This is X1, Y1 and Z1. So these are the point of application of the force. And the components of the forces are, that is P0, 0, which is nothing but capital X1, capital Y1 and capital Z1. So the advantage of writing in this particular manner is, so when we are doing the A cross R, A cross F, that is nothing but the cross product. So cross product when you are finding out, so AD minus BC if you calculate it. So AD minus BC if you calculate it, you are going to get the component of the force for the F1. So this F1 movement you are going to get it based on AD minus BC value. Similarly for F2, for F3, for F4. So for all the things actually if you add it up together, you are going to get the value of L. So G is equal to L plus Mj plus Nk. So for that actually, so L value you will be able to find out like this, and then exclude this, and then actually interpret as if like this is there here, and then find out AD minus BC again. Got it? So in this manner, so for F2, what we can do is the point of application of the force is 0, 0, 0, and the components of the force along the x-axis, y-axis and z-axis are 0, P and 0. So this is x2 and this is y2 and this is z2. Similarly for the third force, this is x2, y2, z2. Third force also the point of application is same. So that is x3, y3, z3, which are again the origin, and the components of the forces are 0, 0, P, and this is x3, y3 and z3. Similarly, for the fourth force, x4, y4, z4, and for this actually the point of application of the force is alpha, comma, beta, comma, gamma, and the components of the forces along x-axis is PL, and this is PM, and this is Pn. So this is capital X4 and capital Y4 and capital Z4. So these are the components of the force. Now to find out the L value, so L is nothing but sigma Y1Z Y1 Z1 minus Z1 Y1. Got it? So sigma of y1 z1 minus z1 y1. So for this actually if you calculate 0 into 0 minus 0 into 0. So this is 0 and so 0 plus and 0 into 0 minus 0 into P. So this is again 0 and this is also 0 and this one beta into Pn minus gamma into Pm. So this is P times of beta n minus gamma m. So this is the L part of it. Got it? Similarly, m is equal to, so m what we have to calculate is, interpret as if like this is there, this x part is there here. Now AD minus BC. That means if you are calculating for y, then you are ignoring this y and keeping the rest of the things. So if there is no component afterwards, then actually you have to keep this like this. So then, so this is as if like x1 is here and capital X1 is here. So this is 0 and P. So AD minus BC again. So again it will be 0. So this is Z1 into X1 minus x1 into z1. So for this actually we have to calculate it. So 0 into p minus 0 into 0. So this is 0 plus 0 into 0 minus 0 into 0. So this is also 0, and this one 0 into 0 minus 0 into 0. So this is there, and then gamma into PL minus alpha into Pn. So this is P times of gamma L minus alpha M. Alpha M. Got it? So similarly, calculate N is equal to sigma, and then if you exclude this, then actually x1 y1 minus y1 x1. So this is x1 y1 minus y1 x1. So 0 minus 0. So this is 0 plus 0 minus 0 plus 0 minus 0 plus alpha Pm minus beta PL. So this is P times of alpha M minus beta L. Got it? So this is LMN value. I hope you understood why I have taken this way. Got it? If you have any questions, you can ask me now. So this is as if like actually we have done the cross product. So the cross product actually we have taken only the components to calculate. Ideally we should have done, this is I, J, K, x1, y1, z1 and x1, y1, z1, and for this actually we have to take, so this is, if I take this as R, so R is equal to 1 to 4. You have to calculate this way. Now this way actually for finding out each and every determinant and adding up together, it will be a little bit tedious process. So that's why actually we have simplified this entire problem statement into this particular format, wherein we have taken this calculation of I into y1 z1 minus z1 y1. So y1 z1 minus z1 y1, and similarly for the second one, third one, fourth one, and add it up together. So that part is interpreted here, and that we have treated as L. Similarly, so J component, if you take it, then actually z1 x1 minus x1 z1. So z1 x1 minus x1 z1. So for that actually you have applied sigma so that you can add for all the 4 different components. So this procedure is applied. So that's why you have to remember this. Got it? Understood? But no complexity in it. From this determinant only we derived this. Clear? Any questions on this? Any questions? Okay. So you can note down this. So we have got the LMN values also. Now actually we have to substitute these values in the central axis equation. So central axis equation also you don't need to worry much. So if you take this part to this side, that will be the central axis equation. First you note down this. I am going to explain how we can take this one. Done? Okay. So this one is to calculate the value of G. So once you got the value of R and G, so the equation of the central axis is, so for this actually you bring this to this side, that is L minus Y capital Z plus Z capital Y divided by X. So this is how actually you have to take it. So this one, if you brought it to this side, these are small y and small z are the variables, so no subscript will be there. And capital Z and capital Y actually you will be removing the subscript so that it will represent the entire force like this. So this is R is equal to xi plus yj plus zk. Now actually these xyz values are used here. Got it? So take this to this side and remove all the subscripts and put a bottom side actually x. Similarly, for this one, so m minus zx, here I am writing. So m minus zx plus xz divided by y is equal to n minus xy plus yx divided by z. So this is lx plus my plus nz divided by x square plus y square plus z square. So this actually, if you require it, you can use it. Otherwise, you can leave it. Got it? So this is actually crucial part for us. Now actually we have calculated all the values. So L value actually what we have got is P times of beta n minus gamma m, and then minus y times of z is, so z component is P times 1 plus n, and then plus z times of y component is P times of 1 plus m whole divided by x. So x is again, you can use this P times of 1 plus L. Got it? So this P and this P will cancel out. Similarly, you substitute these values in this equation and this equation and try to equate it and simplify it. That's all. So beta n minus gamma m minus y times of 1 plus n plus z times of 1 plus m divided by 1 plus L. So this is only this part of the equation. Now similarly you substitute here and put the equation. Substitute here and put the equation. That will be the final answer. Got it? Understood? Understood? Or do you have any questions on this? So this is actually, procedure is simple, but only thing is a little tedious process. So you can note down this. Then okay. So note down one more. Three forces each equal to P act on a body. Each equal to P act on a body one at the point a comma 0 comma 0, one at the point a comma 0 comma 0, parallel to OY, parallel to OY. The second at the point 0 comma b comma 0, the second at the point 0 comma b comma 0 parallel to OZ. And the third at the point 0 comma 0 comma c, and the third at the point 0, 0, C parallel to Y axis. The axis being rectangular. The axis being rectangular. The axis being rectangular. Find the resultant range in magnitude and position. Find the resultant range. Range we mean R comma P. We need to be finding out. So that's what it meant by range. So because we have got the relation G is equal to PR. So if you calculate P and R values, then you will be able to find out the G value also. So that's why actually when we are asked to find out the range, so you have to calculate R comma P values in magnitude and position. Now this is the problem statement. Now actually he described the problem statement in a different manner. So what he said was three forces. That means there are three different forces are there, and the point of application of the forces are 0, A, 0, 0, 0, B, C, and 0, 0, 0, B, 0, and 0, 0, C. So there are three different points. Now, and then the axes are actually different. Axis we mean the line of action of the force is different. So the way he has given in a different manner, that is the point of application of the force is A, 0, 0, but it is parallel to Y. That means if I take this as the axis and this is the Y axis and this is the Z axis, then the point of application of the force is this one, because this is A, 0, 0 point. So which is on the X axis. But the line of action of the force is parallel to OY. That means the force is on this direction. And similarly, one more force which is at 0, B, 0. That means this point is 0, B, 0, but the point of application is 0, B, 0, and it is parallel to OZ. That means the force action is along the Z direction. Got it? And one more force which is at a location of 0, 0, C, that is on the Z axis, and the direction of the force is parallel to OX. That means the direction of the force is parallel to OX. So this is how actually all the three forces are distributed in it. Now for this distribution, right, if you notice the point of applications are like this, but the direction cosines are, now we can make out. So for this particular force, the component along x-axis is 0 and the component along z-axis is also 0 and only component is along y-axis. That means the direction cosines actually L, M, N values for this one if you calculate it. So L value is 0 and M value is 1 and N value is 0. So this is the direction cosines. So this you have to make out from the given information. Now for this one, the point of application is 0, B, 0, but it is parallel to z-axis. Hence, L, M, N values for this one is, so L value is 0 and M value is 0 and N value is 1. And similarly for this one, L, M, N values are, so that is, it is parallel to x-axis. That means 1, 0, 0. That means to whichever direction it is parallel, the direction cosine there is 1. But rest of the axis actually no component. Hence it is going to be 0. Got it? So that means if it is described in a line format, then it would have described this equation as x minus 0 by 0 is equal to y minus b by 0 is equal to z minus 0 by 0. So this is how actually the line equation is described for this particular one. Got it? So this is actually the point of application 0, B, 0 and denominator directional cosines 0, 0, 1. So this is how actually you can describe the line of action of this particular force. Got it? If you are able to correlate these two, then actually you understood the problem statement completely. So, and then actually the procedure again same, whatever we have done in the previous class, right? So it is exactly the same. So that means you will be calculating the R value. So R value, if you want to calculate it, xi plus yj plus zk, and for that actually for F1, so x1, y1 and z1, for F2, x2, y2, z2, like that actually we have to be placing it. Now, so x1 actually this component. So for this one actually the component along x-axis, how much for the force 1, suppose if I call this as F1 and this is F2 and this is F3 and equal magnitude, right? So the force magnitude is same, 3 forces each equal to P. So F1 is equal by magnitude it is P, and by magnitude it is P, and by magnitude it is P. Got it? Now actually the component of F1 along x-axis is how much? What is the x1 value? What is the x1 value? Zero. It should be 0. So a blind rule, you can multiply this P with these direction cosines, that's all. So P into 0 is 0, and the y component is P into 1, and that is P, and z component is 0 again. For F2, you will be multiplying with this directional cosines, that is P into 0, P into 0 and P into 1. So that is 0, 0 and P. For F3, again this particular force, it is on the parallel to the x-axis, that means this is P and this is 0 and this is 0. Now the sum of all the forces together, that is sigma xr is equal to capital X is equal to P, and similarly sigma yr is equal to y is equal to P, and similarly sigma zr is equal to z is equal to P. So the sum of the forces along x-axis, along y-axis and along z-axis, if you notice, each of magnitude P. So that you can make out straight away. If you notice, this force is parallel to y-axis, this force is parallel to z-axis, and this force is parallel to the x-axis. That means, so each force is actually independent. So no contribution or no support to the other force. That means at least if there is some portion of the force, if it is some contribution to this particular direction, then actually the value would have been changed. But here it's not that case. So what is happening is, this is the only force acting parallel to x-axis. This is the only force acting along y-axis. This is the only force acting along the z-axis. Hence, if you notice, all the forces are coming out to be equal because only one force is acting in one direction. Got it? So this way, if you are able to calculate the R value, it is going to be Pi plus Pj plus Pk. So this is the force. Now if you want to find out the magnitude of the force is root 3 times of P. So this is the magnitude of all the forces together. Got it? Understood? Any questions on this? Now actually it is time to find out the value of G. From this information you will be able to find out the value of G. Now actually let us find out. So to find out the G value, we again follow the same procedure. That is x1, y1, z1 and capital X1, capital Y1 and capital Z1. So this is how actually you have to put it. So the first force is the point of application is 0, 0, 0 and the components of the forces are, so the first force is only parallel to Y. That means it will be 0, it will be P and it will be 0. This is capital X1, capital Y1 and capital Z1. So similarly X2, Y2, Z2, if you take it, so for this particular second force, this is the point of application 0, B, 0 and the components of the forces are only along the Z direction. That means only Z part will be P and rest of the values are 0. So this is X2, Y2 and Z2. Similarly, third force X3, Y3, Z3 and the point of application of the force is 0, 0, C and the line is only parallel to the x-axis, hence it will be P, 0 and 0. So this is X3, Y3 and Z3. Now we can find out the value of L as L is equal to AD minus BC. So this is 0 minus 0 plus, so I can write this YZ minus ZY sigma. So this is 0 minus 0. And similarly 0 minus 0, 0 minus 0. So this L part is 0. Similarly, M part sigma Zx minus Xz. Zero plus so this is PC minus 0. So this is equal to PC. So N is equal to sorry, so this one I think second one is wrong. Yeah. So BP minus this is BP. Yeah, now it's correct. So N is equal to XY minus YX. So XY minus YX, AP minus 0 plus 0 plus 0. So this is AP. So G value what we have got is Li plus Mj plus Nk, and this value is going to be Bp into I plus Pc into J plus AP into K. So this is the value of G. Got it? Yeah. So this is the value of G value. So we have got both the values, L value, so we have got the G value and R value. Now based on this, actually the point of application of the force and the line of action of the force we can find out, which is nothing but the central axis equation for us. So first actually we'll find out the central axis equation, and then point of application of the resultant force, which is the solution of the central axis equation, which is nothing but the intersection of all the values there. So first you note down this, we are going to arrive at that solution. Then okay. So we have got G is equal to BPI plus CPJ plus APK, and R is equal to Pi plus Pj plus Pk. So these are the values actually what we have got. The equation of the central axis is so that is L minus YZ plus ZY divided by X is equal to M minus ZX plus XZ divided by Y is equal to N minus XY plus YX divided by Z is equal to LX plus MY plus NZ divided by X square plus Y square plus Z square. Right? So now actually we will substitute all these values in this equation. Now L value is, that is BP. So this is Li plus Mj plus Nk, and this is Xi plus Yj plus Zk. So if you replace those values here, L is equal to BP minus Y times of Z is P plus Z times of P divided by X is again P is equal to M is Cp minus Zp plus Xp divided by P is equal to AP minus Xp plus Yp divided by P is equal to Lx plus My plus Nz. So Lx is Bp square and Cp square and Ap square. In the denominator, x square plus y square plus z square is nothing but 3p square. So here also p square will cancel out. So what we left over is b minus y plus z is equal to c minus z plus x is equal to a minus x plus y is equal to a plus b plus c divided by 3. So this is the equation of the central axis. Got it? Understood? Now actually the position of the central axis actually we will be finding out. So first you note down this. From these equations actually we have to be calculating the values of x, y, z, which are nothing but the point of application of the resultant force. Got it? So either you can manipulate these equations or actually you can solve these equations to get the values of x, y, z. So we have got 3 unknowns and 3 equations. Then, so these equations we can solve. If you take this equation, yeah, you can take any equation. So let us take this equation. A minus x plus y is equal to a plus b plus c by 3. Now, so if you bring this to this side, 3a minus 3x plus 3y is equal to a plus b plus c. Now 3x take it to the other side, then 3a plus 3y is equal to 3x plus a plus b plus c, and then a coming to this side, 2a plus 3y is equal to 3x plus b plus c. Now add on either sides a plus b plus 2c. This is just a guess, a plus b plus 2c. If you add on either sides, then actually it is going to come out to be 3a plus b plus 2c plus 3y is equal to 3x plus a plus 2b plus 3c. So divide on either sides by 3. Then x plus a plus 2b plus 3c by 3 is equal to y plus 3a plus b plus 2c divided by 3. So why I have done that way is, see this, we have got the value like x plus alpha by beta is equal to y plus gamma So this format actually we know that alpha, beta, gamma are the point of application of the force, which is nothing but the point. So here also, if you can write some form of x plus something and y plus something, and similarly from the other equation also, if you can bring out Suppose take any other equation and then try to get the similar method. So x plus something is equal to y plus something. So if any one is equal, then actually you can say that the remaining part, that is x plus whatever is there, this is the point of application of x and this is the point of application of y. Similarly, you can bring the z1. So if you take x z relation like this, now if you take these two, from this also multiply with 3. So 3c plus 3c minus 3z plus 3x is equal to a plus b plus c. Now similarly, you manipulate z onto the other side exactly the way we have done. You are going to arrive at x plus this one and you are going to get z plus, so similarly like this. So which you can say that this is x location, this is y location and this is z plus whatever you are going to get it. This is the z location. Got it? Or else actually the simplest method is, or not the simplest, this is the simplest and a little complicated method which is a much more standard way is solve these equations to get the values of x, y, z. Got it? Understood or not? Understood? Okay. So this is actually the location. Similarly, if you want to find out the pitch of the wrench also, you will be able to find out. So PR is equal to GR. So KR is equal to LX plus MY plus NZ. Right? So this K is nothing but G cos theta. We have already calculated this. Right? So G cos theta. So this K value actually we can find out. So K is equal to LX plus My plus Nz divided by R. So this R is mod. I hope you remember this. So when we calculate the pitch of the wrench, right? So we have used this relation. Kr is equal to Lx plus My plus Nz. So I explained why this Kr is nothing but dot product of these two vectors. So this K is nothing but L plus Li plus Mj plus Nk and R is nothing but Xi plus Yj plus Zk. And the dot product is coming out to be the direct multiplication of the values. Why? Because in case of wrench, the value of angle in between the two values, that is G and R angle, is always coming out to be 0 because those two are parallel, then only we call that as the wrench. So because these two are parallel, the angle between them is 0, which is equal to the dot product of it. So Lx plus My plus Nz we can calculate. So Lx is nothing but X is P and L is BP, I think. Cp into P plus AP into P divided by mod R is, that is root 3P. So this is A plus B plus C into P by root 3. So this is the K value, which is nothing but G cos theta. Got it? And pitch of the wrench, if you want to calculate, this is Lx plus My plus Nz divided by X square plus Y square plus Z square. This is the pitch of the wrench. Got it? So this is BP square plus AP square plus CP square divided by P square is equal to A plus B plus C. So this is the pitch of the wrench. Clear? Got it? Any questions on this? Any questions? So whatever I have explained is a little tedious process, but still actually the procedure is straightforward and simple. So whatever you have learned in case of equilibrium of forces in 3D is just a supporting information for solving these problems. So problems are only these models. Clear? Any questions, you can let me know. Fine. So with this actually I would like to stop the class for today, and we are done with the equilibrium of forces in 3D. So next class actually I am going to start with a different topic. So we are left with only two topics, minor topics. One is the stability of equilibrium, and another is I think virtual work. Yeah, principle of virtual work. Got it? So with that we are done with the statics. We will be starting with the dynamics. So I am logging out. Yeah, thank you. Good night.